All right. So chapter 1, we'll kind of put it behind us, but I'll dredge stuff up as we need it, right? Um, well, that's all right. We're just starting. So um, what I want to do is today I want to just try to get through as much of chapter 2 as we can. The reason I want to just kind of plow through it is because what I usually do in chapter 2 is to get you to graph straight lines and use those to solve linear equations. But because we're not working and I'm not getting you to hand stuff in that you're doing by hand, it kind of makes it hard to test. So chapter 2 is going to be kind of a flyby, a flyover chapter, if you will. Um, so, but there are a couple of things that I want to point out in chapter 2 before we head into chapter 3, and hopefully we'll be able to just start chapter 3 on Thursday. So, if there are things that you're feeling kind of uncomfortable with in chapter 2, then definitely review the textbook. But I'm just going to bring up the things that we need. Okay. All right. So, and some of these things we've already looked at. Oh, gotta clear up my workspace here. Okay. So here, those are just things that we went through. I'll put it on a fresh page here. So chapter 2 is called an introduction to microeconomics. And like I said, we're just gonna dip into it and get in, get out, get what we need, and then we'll move on. Okay, so 2.1 is called functions and graphing. Okay, so first thing I want to do is just remind you how to draw a straight line, right? And I know that sounds stupid, but there's only one way to draw a straight line, right? Especially if you're graphing a straight line. So what you need, and you only need 2 points on a line in order to draw the entire line, right? Because if you have 2 points and a straight edge, you connect the two, and then the line just keeps going and going and going. So the trick is to be able to find 2 points on the line. So we've been working with linear equations, right? So we've been working with things in the form of, and I'll just scroll back here, things in the form of, let's say, 7x minus 3y is equal to something, right? I can rearrange this into the form y equals mx plus b, right? Because I've got the highest power of y is 1 and the highest power of x is 1, right? So when the highest power of x and y are 1, we are able to rearrange the equation into the form y equals mx plus b. So we are able to rearrange, oops, it doesn't say rearrange the equation into the form y equals mx plus b. Okay. Which is a linear equation, or a straight line if you prefer to call it that, right? Linear, oops, straight line. Linear just means straight line, right? So if you have something like y equals mx plus b, right? M, you might remember, is the slope, right? So whatever is attached to the x, and this is after you've simplified and collected all your like terms, right? And you've got some coefficient on x, right? Which is very similar to what you did in that first assignment question that we went through earlier. So we've got a slope of m, and it can be either positive or negative, right? So a slope can be positive, which looks like something like this, right? Or it can be negative, which on your XY plane would look like this. Okay. And it just depends on if it's a positive or a negative number. Okay. Whereas the B here is the y-intercept, right? The y-intercept is the value when x is 0, so where it crosses the y-axis, where the line crosses the y-axis. Yeah. So this should just be kind of review on straight lines, right? But what we have is for each point in an XY grid, right? So here we've got X and Y, we've got an X-axis and a Y-axis, right? So each point on this grid, and we've already seen this, corresponds to an XY ordered pair. Okay. So each point in the XY plane, oops, I'll write it as XY together, then dash plane. Each point in the XY plane corresponds to an x comma y, so it's always in round brackets x comma y, so the x coordinate comma the y coordinate ordered pair. I'll highlight that because that's some terminology that that we're going to refer to quite a bit. So an ordered pair. An ordered pair is just an XY pair, which is a point on the graph. So for example, we found the solution earlier that we were working on was 0.9 comma 1.7. Okay, so what this means is that when x is 0.9 and when y is 1.7, okay, both are positive. So what I get is, if I had to plot these, and of course I'm gonna kind of make up my own grid here, so it's not gonna be very beautiful, but I'm gonna give myself lots of room here, 1, 2, and then 1, 2. Yeah. Of course, when we're graphing by hand, this is not going to be very good, right? But it does give us an idea. So here on the x-axis, so remember the x-axis is the one on the bottom, and then the y-axis is the one on the top. And then I know I had a student a long time ago, and she was she was struggling with which one's the X and which one's the Y, and all these things. You might have to kind of remember things in a weird way, but so how she remembered it was she imagined some little guy down here on the on the x-axis. So imagine it just kind of fell down and he's like, no. So it's like x. So this is the x-axis down here. And however you need to remember it, doesn't matter. But so what we've got is we've got x is 0.9. So I'm going to do my best here and try to map out 0.9. Okay. My y coordinate is 1.7. So again, I'm just going to do my best and try to find 1.7 without a proper grid. And maybe it's up a little bit. It's really hard to know, right? But so this point here, it's going to join up. And that point there is this ordered pair, 0.9, 1.7. Okay. I guess it kind of looks like it dipped down a little bit. That's okay. The idea is there. So each ordered pair, right, corresponds to one point on the graph, right, which means you have to have an x and a y coordinate. And what we saw was that this was the point of intersection of these two lines, right? So if we're trying to draw one line, right, then what we need is we need two ordered pairs on that line, and then we connect them with a straight edge. And you don't need to have a ruler. You can, most often I end up using the edge of my calculator, or you can even just take the edge of your page and just kind of curl it up like this and use that as your straight edge, right? Just kind of, you don't have to be rough with it or anything, just kind of use it as a straight edge. So there's lots of ways that you can do it. You don't need to have a ruler. Okay. But so the most important thing is, in order to draw a linear equation, oops. In order to draw a linear equation, we need to find at least two ordered pairs on the line. Okay, so at least two, and then we connect those 2 points with a straight edge. Then connect those points with a straight edge. And then you extend the line. So a line, it's really important to remember that lines keep going to negative infinity and positive infinity. So whether it be positive or negative slope, these lines will always just continue, right? We'll only draw them for a short time, but they continue, and that's important to remember. So then connect those points with a straight edge and continue and extend the line. Okay. So what if we had to draw something like, for example, draw the line 3x plus 2y equals 5. Okay. So to draw this line, okay, and we're not really, like, I won't be able to test you on can you draw a line, but it is going to be really useful later on. I know you guys have to take statistics, so you'll need to know how to draw a straight line then, and just kind of it'll be really good to know just in general. So to draw a straight line, it's not something that I'll be able to test you on, but I can try, but it's gonna be hard. So first thing I want to do is I want to find 2 points on this line, right? First thing I'm going to do is I'm just going to rearrange this to be in the form of y equals mx plus b, right? And so what I'll do a little kind of commentary here. Confirm this is a linear equation, right? So rearrange it, right? When I look at this, okay, I have an x and I have a y. There's nothing else in here, no other variables. So right away, I'm thinking, okay, this is a straight line. My highest power of x is 1 and my highest power of y is 1. So then, so I should be able to rearrange this. So what I have is I have 3x plus 2y equals 5. Now I'm going to rearrange this and solve for y. So I get 2y is 5 minus 3x. So then y must be 5 minus 3x over 2. I can split this up if I really want it in the form of y equals mx plus b. So y is 5 over 2 minus 3x over 2. So now here, my slope, m, is negative 3 over 2. And my y-intercept is 5 over 2. Okay. So already I know kind of, I have a general idea of what this thing looks like, right? 5 divided by 2 is 2.5. Okay, so already I have a pretty good idea of what this thing might look like if I have an XY plane here. Then maybe here at 2.5, okay, it's gonna cross, that's where it crosses my y-axis, right, 5 over 2. And just knowing that I have a negative slope here, right, it tells me that it's gonna be a line like this, right? So a negative slope is gonna be pointing downward like this. Now, you can do your rise over run if you want to kind of find your next point. But I would say the easiest way to find ordered pairs on this line is to just pick easy values of x, plug in the value of x, and see what you've solved for the y, okay? So the easiest way to solve, or the easiest way to find ordered pairs on the line is to substitute easy values of x and solve for y, and solve for the corresponding y, I'll say. The corresponding y. Usually how we set that up is in a little table. Okay, so how I do it is I solve for y, and so now I've got this kind of fancy equation that I can work with, right? And so what I'm going to find is I'm going to find pick an easy value of x, and I say easy, and I'll show you what I mean by that. Pick an easy value of x, and then I'm going to solve for what the y is for that value of x, right? Remembering for a line, each value of x corresponds to one value of y. So we usually set this up using a table. So something like this, x on the one side and then y equals, and then the equation that I'm working with that I just solved for, 5 over 2 minus 3x over 2. Or what I'll do is I'll have 3 over 2 times x. That's the same. Right? I can have the x in the numerator or off to the side. It doesn't matter. It behaves the same way. So what I'm going to do is we pick easy values of x. Now, so that means I'm not going to pick x equals 5 here, because then I've got 15 divided by 2, and then 5 over 2 minus 15 over, no thank you, right? What I'm going to do is I'm going to pick multiples of 2, right? And usually my first one that I go for is x equals 0, right? Usually plugging in x equals 0 is pretty easy to solve for, right? It's just going to be the y-intercept, which we already found. So 0 makes 5 over 2 minus 3 over 2 times 0, which is 5 over 2. So then my ordered pair is in the form x comma y, right, just as a reminder, is going to be 0. And then 5 over 2, because it's hard to put 5 over 2 as a fraction on the number line. But if you just do it on your calculator, right, 5 over 2 is 2.5. Okay. The next value that I'm going to pick is, again, I'm going to pick easy values of x. Now, because I'm doing x divided by 2, I want to have x as a multiple of 2. So why not just have x equals 2 to see what happens? Okay. So I get 5 over 2 minus 3 over 2 times 2. So those two go away. It makes it a little bit harder. Oops, maybe I shouldn't have done that. I can cancel those, but because I'm subtracting fractions, I'm going to need to force a common denominator anyways. So maybe, and this is just going to be kind of practice for you guys, 5 over 2 minus 6 over 2. 5 minus 6 is negative 1 over 2. Okay. So what that means for my ordered pair is that when x is 2, y is negative 0.5. Which makes sense because we're expecting to have a negative slope, right? And so I'm expecting to start at 0, 2.5, and then I guess once I pass the x equals 2, or we could figure out what the x-intercept is. I'm not too interested in that yet. But at some point we cross the x-axis, and then and it's somewhere between 0 and 2, but we'll see exactly where when we plot it in Desmos. So technically I have 2 points that I can plot and I can connect the line, right? We said, okay, we should have at least 2 points. So let's just shoot for 3, just so we have a little bit of practice, right? So keeping it to multiples of 2, right? Or, I mean, if you wanted to, you could try x equals 1, because then you've got your nice common denominator. But let's do x equals 4. 5 over 2 minus 3 over 2 times 4. Again, preserving that, even though I can cancel, right? Preserving that fraction over 2 is going to make it a little bit easier. 5 over 2 minus 12 over 2. 5 minus 12 is negative 7 over 2, and 7 over 2 is negative 3.5. Okay. So here, I'm just going to highlight, pick any value of x. Right? Especially if you're graphing and if you're given the axes, then you'll definitely want to just pick x values that are in that grid that you have, right? You don't want to go for x equals 12 if your grid only goes to 5, right? That's going to be hard to graph. Okay, so what we're going to do now is I'm going to cheat, and I've got these little grid stickies. Okay. And I'm going to put a grid on here. I still have to do a little bit of kind of thinking about where to put my x and my y-axis. Hopefully that works out. Let's use 1, 2, 3, -1, -2, -3, -4, 1, 2, 3, 4, etc. This is my x-axis. So to graph this line, right, remember this is the line that we're ultimately trying to graph, right? 5/2 minus 3/2x. First thing we're going to do, like we started, was up here, we can graph our y-intercept on here, right? But it's also one of the ordered pairs that we found. So let's put that guy on there, sort of, right? And I like to label them as I go along, because then it's easier to kind of backtrack in case something went wrong. My next ordered pair is at 2 and -0.5. So when x is 2, y is -0.5. So somewhere around here, 2, -0.5. And when x is 4, y is -3.5. Notice, right, you only need these 2 points. You only need 2 points to draw a straight line. But it's nice to have a third one just to make sure you're on the right track. But if you wanted to, you can take a straight edge, right, and put it down, connect the dots kind of visually, and then actually connect them with a line. But I'm going to put this third dot on here just to make sure I'm on the right track, because they should all be on the same line. So when x is 4, y is -3.5. Okay. So now well, it's hard to see because I'm going to put it on my iPad, and sometimes it jumps around a little bit, but my pen. But what I'm going to do is I'm going to take a straight edge and I'm going to connect the dots with that straight edge. And like I said, and just make sure they're all on the same line-ish, right? We've kind of made our fake axes here, so we're not expecting it to be perfect. But what I'm going to do is I'm just going to extend that line. I connect those dots and I extend it using that straight edge. And that line keeps going and going and going and going. Okay. So now what you can do is you can always check your work in Desmos. Okay. So now we have drawn the line. Which was our whole goal here. You can always check your work in Desmos, right? So, and what I would suggest you do is put in the original equation, right? And so Here, we tweaked it, right? So here, when we solved for y equals 5/2 minus 3x/2, we'd actually rearrange that. So in order to avoid any errors that we might have made, go way back to the top and graph this. And you can just plug it in the way it's shown here, 3x plus 2y equals 5. So what I have is I have 3x plus 2y is equal to 5. And notice that it's showing some kind of points of interest here. Our y-intercept is the same. And what you can do is you can put your pencil or kind of your finger or whatever, and you can see what the values are if you're careful there. When x is 2, y is negative 0.5. And so that is what we found. And then we had x equals 4. Try to land on it. Negative 3.5. So it all checks out. What we did was good. And it also gives us the x-intercept of 1.667. That's actually 1.6 repeating when y is 0. So that's something to remember, right? You can always check your work, make sure that the points you found are on the line in Desmos as well. Okay. So, so being able to draw lines and just kind of taking a linear equation and being able to convert it to a graph is going to be really useful. And just being able to think about what that graph would look like. Yeah. So, and I can't remember if it was a 2 point. Yeah. Okay. So one thing that we haven't talked about yet, we've used them, but we haven't talked about them, are functions. Now, functions, if we're just talking about x's and y's, usually we use function notation, but it's not actually different from y equals mx plus b when we say f of x is mx plus b. And so sometimes we will use function notation to indicate that y depends on the input of x, that the output of y here, that the output of y depends on the input of x. Okay. So we're just going to touch on this briefly, just as much as we need to, but there is more in the textbook if you want to brush up on functions. But instead of writing, instead of writing y equals mx plus b, we will sometimes write f of x, okay, and we'll talk more about that in a little bit here. So f of x equals mx plus b. Okay. So this is function notation. And you read it as f of x. Okay. Which means it's a function of x. So f depends on the input of x, right? And that's what we said. So most of the time, you'll be able to just, when you see f of x, you'll be able to just mentally replace it with a y. And that's something that I always find makes it easier. So just as a note, when you see f of x, you can replace it with y in your mind if you want. You can replace it with y. Okay, so y equals mx plus b is the same as f of x equals mx plus b, because it just says, but here we're just emphasizing that, hey, x is the input, so whatever I put in here gives me the output, right? And so what we did, right, so earlier when we solved, or when we found ordered pairs, we were solving, the table should actually look like this: x and f of x, right? X and the y coordinate. When x was 0, what we found was what we call f of 0, right? And so here it gave us the output at x equals 0. The output at x equals 0. Okay. And then we found f of 2, and when x is 4, we found f of 4, right? So really, this is just a shorthand notation for the y value when x is equal to 4, for example. Okay, so being able to read function notation is going to be really useful, because, okay, so when we'll start to use function notation is when we're talking about profit functions. Okay. So we will use function notation. We will use function notation when we discuss and build, right? We're going to eventually build profit functions. Okay. So what that's going to look like is you're going to have the profit of x right? Where x is the number of units that you're selling, or the number of units that you're producing, or it's usually the number of units, the number of hours that you work, or it depends on what the function is about, right? But so you put in some, typically it's the number of units that you're selling. So you put in, I sell 40 units, then it can, the profit function will return the profit at 40 units. Okay. So let's say the profit of x is equal to 3x minus 1, right? Just for a really simplified profit function. Then if I asked you to solve the profit of 2, and these should be squished together. I don't know why I wrote them so lofty, but the profit of 2 is how we read it. And they're smushed together like this, right? Is going to be 3 times 2 minus 1. So the profit, when I produce 2 units, let's say, is going to be 6 minus 1, which is 5, right? So how we interpret this is the profit at x equals 2 is 5, right? $5, $5,000, $5 million. I don't know, doesn't matter, right? And so, so we're going to use the function notation quite a bit. And so just get used to working with functions. So let's do an example here. And like I warned you earlier, what we're doing today is going to feel like a really mixed bag, but I'm trying to tie it together and kind of make it kind of work out. But let's see here. What if we say let g of x, okay, so just kind of get in the habit of, okay, well, I can have anything here. I can call it whatever I want. This is just the name of the function, right? Here, it was a profit function, so we just write profit. Here, the function is called g, doesn't matter. Usually we call it f, g, h. We stick to that section of the alphabet for some reason. Let's make it be 2x squared minus 5. Okay. Find g of 5 and g of 0. Okay. So we'll start with g of 5. G of 5 says, okay, wherever you see an x, replace it with 5, right? In this case, you have to be careful because you've got 2x squared, right? So 2 times 5 squared minus 5, and that square is only on the x. So this becomes 2 times 5 squared minus 5. Okay. 5 squared is 25, so 2 times 25 minus 5 puts me at 50 minus 5. Following those order of operations, right, puts me at 45. So for the function g, right, and notice that I'm no longer working with a linear equation, and that's okay. If you want to, you can still graph it in Desmos. But when x is 5, my output is 45, right? And I could plot that on my xy plane still, right? Remembering that g of 5 is really just, you can read it as y, right? G of x is y, f of x is y. Whenever you have the function on one side, you can read it as y. And maybe I'll just do these side by side here. Oops. Do g of 0 here. So when x is 0, the output is 2 times 0 squared minus 5. 0 squared is 0, times 2 is 0. So an output of negative 5. Okay. Let's do, okay. Let's have a little bit of a break. So let's break for just 5 minutes. Break until 11:10. How about that? Sorry, guys. But we're just having so much fun that we don't need a big break. We're here for class after all. Okay, so let's do a little oh, don't worry. So let's see here. Let's do a little word example, although it does have the profit function laid out for us. So example, so a tutoring service charges students $45 an hour. $45 per hour of tutoring. Okay. The tutor room rental, the room rental is $725 per month, right? So we're going to have expenses. We can't just be making money. Is $725 per month. And one particular tutor has a profit function and so this is how we're going to denote it. Profit of X is 45X minus 725. What we're eventually going to work towards is building this profit function, right? So given this word problem, we're going to be able to build this profit function, right? So they're making $45 per hour. So X is each hour of tutoring, right? So X is each hour of tutoring. But then regardless of how many hours of tutoring they do, they still have to pay this $725, right? And we understand if you're running a business, you have more fixed expenses as well as variable expenses. So this is a kind of a simplified version, but just always keep that in mind that we can always think about this in real life, right? So you're running a business, you've got your you've got your room rental, you've got your phone bills, you've got your internet, whatever, right? So you've got your fixed expenses, and then you've got variable expenses if you have employees, for example, or just maybe you're using gas and it's a variable expense, right? Because it depends on how much it costs, all those things, right? But for now, we're just given the profit function and then we're going to use it. But later on, we're going to build the profit function and then use it, right? So we're baby steps. So this is a multi-part question, just so we can really work with this question. How much money does she earn? How much money does the tutor earn? If she tutors 50 hours? Okay. Presumably in the month, because it's a profit function per month, because the fixed cost is $725 a month. But for now, we can just kind of ignore that. How many hours for zero profit? How many hours for $0 profit? Okay. I'm kind of shorthanding these questions, right? How many hours must she tutor in order to earn $0 in profit? And then C, what if she needs to make $1,000 in profit? Notice that solving B and C are going to be very similar, right? We're just forcing the profit to be some value. How many hours for $1,000 profit? Okay. So given this profit function, right, if I am told that I'm working 50 hours, then I can do 45 times 50 and then subtract my fixed cost of 725, right? So for A, kind of no problem here. The profit of 50, right? So I'm putting in X equals 50 is 45 times 50 minus 725. 45 times 50, I'll just do it on the side here, is 2250 minus 725, putting me at 1,525. So if I tutor 50 hours in a month, then I will make $1,525 in profit, right? I will make $22.50, but then I have to subtract how much I have to pay, right, in order to do that. Okay. We're not usually interested in making zero profit, but really what this threshold is how much do I need to tutor in order to make a profit, right? In order to exceed zero profit, how many hours do I need to work? And then I might have, some kind of goal profit number in mind, right? So just being able to work with these functions is going to be important. So what I want to have is, I'm just going to copy out my profit of X is 45X minus 725. And then let the profit of X equal 0. So then I need to solve for X, right? How many hours do I need to work in order to get zero profit? So now I have 0 equals 45X minus 725, right? And I think if you were just given this word problem, you would be able to pick your way to the solutions, right? But now we've got this structure of the function that's going to help us kind of solve things a lot easier. So now if I'm solving for how many hours I need to work X, right, then I can slowly move things over, right? I can add by 725. So I can add 725 to both sides is 45X. Solving for X. Now, here, I can't remember if I don't think I've shown you guys how I usually do it, but I usually like to have what I'm solving for on the left-hand side. So notice that the X is on the right-hand side. So what I'm going to do is I'm just going to revolving door this thing, right? So I'm going to rewrite this as 45X is equal to 725. Convince yourself that these two things say the same thing. Right now I've just got my X on the left-hand side. Now, and usually I do this in the same step as my kind of, I like to think of it as just the revolving door, right? And so I just swing things around the equal sign. If A is equal to B, then of course B is equal to A, right? So just kind of revolving door it. Solving for X, I need to divide both sides by 45. So now I get X is 725 divided by 45. 725 divided by 45 is 16.111 repeating. So X is roughly 16.11 repeating, right? So here, this is just repeating. And you put a bar over whatever is repeating. Okay, so I would need to work roughly 16.11 hours to make zero profit. And if you think about, okay, well, how does making money work? 16 hours, I make negative profit, right? I'm still paying to work. 17 hours, all of a sudden I'm making a profit, right? And so here at 16.111 repeating, that's where it switches over from not making any money, in fact, losing money, to making money. So she needs to work 16.11 hours to make $0 profit. Okay. So 16 hours is a negative profit, right? So I'm losing money. And 17 hours, then I've crossed over. Now I'm making a positive profit, which is where we want to be typically. Okay. So the last one, right now, let's say we've got it in our heads. Okay, each month I need to make at least $1,000 profit. You could do 7,000 if you wanted to, right? But the idea is, okay, so if the profit has to be 1,000, that's the same as forcing the profit to be 0, right? It's the same mechanism. So we're going to solve for X and force the profit to be 1,000. So again, I'm going to just copy out the profit function. So the profit of X is 45X minus 725. Now I'm forcing the profit to be 1,000 and solving for X. So to solve for X, again, I need to add 725 to both sides. So I get 1,725 is 45X. And now I'm going to do that swift move again, right? Where I switch them over, but I'm also going to divide both sides by 45 in that same move. So what I get is X is 1725 divided by 45. So X is approximately 38.33 repeating hours. Okay. So, good. In order to make at least $1,000 profit, right? It's tricky because 38.33 repeating is kind of hard, but somewhere around 38 hours is where she makes around $1,000 profit. So in order to make at least $1,000 profit, she needs to work at least 38.33 hours. And if you think about it, at 38 hours, she'll make just less than $1,000 in profit, and over 38 hours, so 39 hours, she'll make a little bit more than $1,000 in profit. Right? And what could you do? What if she worked 40 hours, right? That's the exact same scenario as in part A, right? So then you could plug in X equals 40 instead of 50 here and figure out what the profit is. And this is in line with the numbers that we were finding, right? To make $1,000, she had to work 38 hours. So 50 hours, she makes a little bit more, 15.25, maybe a lot more. Okay. So working with profit functions is going to be really important, and just working with functions in general, right? But an input produces an output. Let's see here. Okay. I'm keeping an eye out for questions. I haven't seen anything come up. But if you do have a question, let me know. in the chat. So supply and demand economics, section 2.2 is on supply and demand economics. What I will say is I am not the person to teach you about supply and demand economics. If the supply goes up, what happens to the demand, blah, blah, blah. Those problems, those word problems never really make sense to me. And there are problems in the textbook that you can work through to try, but it's not something that I'm going to test you on. But I will test you on finding the point of equilibrium. Okay, so in supply and demand economics, there's going to be a supply curve and a demand curve. And you've probably taken some sort of economics or are taking some sort of microeconomics course where supply and the demand curve are big players. So for supply and demand economics, we switch out our x-axis and our y-axis and we swap them with the price and the quantity, right? And so in supply and demand economics, our y-axis is the price axis, and our x-axis is the quantity axis. So just remember that that kind of relationship, okay? So if we draw our XY axis here, what we're going to have is we're going to have price on the y-axis and quantity on the x-axis. Now, price we're going to denote by a capital P, and Q we're going to denote by a Q, right? But just remember, the Q, you can replace it with X, and the P, you can replace it with Y. And so supply and demand economics, like we said, have a supply curve and a demand curve. Now, the supply curve is always going to be a positive slope. So here, the supply curve is always going to look like this. S is the supply curve. Okay. Which means, okay, if I'm a supplier, as the price increases, then the quantity that I want to produce and sell also increases, right? And so that's why it's always going to be going up. This is about the extent of supply and demand economics that I'm going to go into. So just kind of sit tight. But the demand curve is going to do kind of the opposite, right? And so here, for high values of price, we don't want to buy as much, right? Our quantity is going to be quite low, right? Whereas as the price is decreasing, right? I'm sliding down this demand curve, then my price is decreasing as I move along here. And as the price is decreasing, the demand for the quantity is increasing, right? My quantity is increasing. So my supply curve and my, D is my demand curve. Okay. For our purposes, we're going to assume that these are straight lines. That's not necessarily the case, but just to simplify things and just to get the gist of it, we're going to assume that these are straight lines. So the demand curve has a negative slope. And the supply curve has a positive slope. And that's always going to be the case, right? Your supply is going to be positive and your demand is going to be negative. Now, the moneymaker for us is we've already done a lot of this work. So when I say, okay, I'll give you the equation for the demand curve, and I'll give you the equation for the supply curve, and then you tell me what's the point of equilibrium, right? What point, so what single point can we all agree on? Suppliers, demanders, all of us, right? This is the point of equilibrium. This is the point of intersection. And this is why we had to solve systems of equations earlier, is really because what we're finding is the point of intersection, which is this equilibrium point. So here, what color haven't I used? Maybe orange. Right here, this is equilibrium. Okay. And it's going to be at some ordered pair QP, right? At some quantity that we're going to solve for and some price, that ordered pair is going to be the equilibrium. Okay. So what I'm going to say here is, given the equations, right? So given the equations for the supply and demand curves, we can solve the system. Okay, that's what we were doing just earlier. We can solve the system of equations to find the point of equilibrium. Okay. And just to clarify, the point of equilibrium is the price and the quantity, or the quantity and the price rather, in that order, because we always say the x-axis first. So the quantity and the price at the point of intersection. The quantity, Q, and the price, P, at the point of at the point of intersection. Okay. So for example, like I said, the textbook goes through and gives you all these scenarios, like suppose that I'm just going to read it to you just to get an idea. So suppose that you're a wheat farmer. This summer was unseasonably hot, causing great growing conditions. For one, how am I supposed to know that? What does this mean for the equilibrium price and quantity of wheat? And so these curves are going to shift around. I have a heck of a time figuring that stuff out. So I'm going to leave that for your other courses. I know you'll have to do them. I know you're probably way better at it than I am, but it's not really math. The mathy part is finding that point of intersection. So that's what I want you to focus on for this course. Okay. And so let's see here. Where is an example I can nab? So for example, determine the equilibrium price and quantity. Sometimes it'll only ask for one of these, right? And just like when you were solving systems of equations, it'll just ask you what's the x or what's the y. Usually it's just easiest to just solve for everything and then extract the answer that you need, right? In this case, we want the price and the quantity, just to show you what this thing looks like. So how I'm going to give you this information is going to be S, that's the supply curve. So here I'm just telling you, instead of calling it equation 1 and equation 2, I'll just be able to call it S and D, right? Because they have their own names. So the supply curve is going to be Q equals 4P, for example. The demand curve has the equation Q equals 18 minus 2P. Okay. What's nice about these equilibrium problems is that they kind of help you skip a step. Now, the reason I say that is because usually we would have this as a linear equation. Now, because I've already solved both of these for Q, or you're given Q equals 4P and Q equals 18 minus 2P, you can just take one of these Q's and substitute it into the other one and solve for P, right? And so here, we want to solve this system of equations. Solve this system of equations. Right, to find the point of intersection, we have to solve this system. So notice, right, so here I'll just make a little note. Notice both of these equations, both of these are already solved for Q. Making for easy substitution. Making for easy substitution. Kind of ended up looking like a mean smiley face. That wasn't my intention, but I'll keep them there just to keep you on your toes. So if I have Q equals 4P, oops. Okay. And Q equals 18 minus 2P, those are my equations, right? Remember the S and the D, don't let those throw you off. With the colons out front, it just means, hey, these are the names of these curves, supply and demand curve. And that's the only new thing that we're dealing with. So now, right, if Q equals 4P and Q equals 18 minus 2P, what I'm going to do is I'm going to substitute this in here, right? Replace that Q with 4P. So I get 4P is 18 minus 2P. In a way, this is way easier than the systems of equations that I'm getting you to do on the assignment, for example, right? So now I'll have to rearrange and solve for P, right? But we haven't really done a lot of work, so that's okay. So now I'm going to add 2P to the left-hand side. So I get 6P is 18. So P must be 18 divided by 6. Now 18 divided by 6 is 3. What does that tell me? It tells me that the price at equilibrium is 3, right? Price at equilibrium is 3. So now I can plug that back in to find the quantity, right? So if the price is 3, then the quantity is going to be, for the supply curve, is going to be P, so 4 times P, right? and the demand curve, they should end up being the same, right? This is the point of intersection, but you should plug them into both of these just to make sure that you did it right, right? And so Q, now solve for Q. So Q equals 4P, so Q must be 4 times 3. So the quantity must be 12. At equilibrium is 12. I'll just use EQ. It is a good idea to substitute it into both equations just to make sure, right? So it is a good idea to substitute the price, right? Or in general, the value that you found, right? Sometimes it'll be easier to solve for Q first, but in this case, it's the price. So it's a good idea to substitute the price into both the supply and demand curve. To make sure we find the same quantity, right? To make sure we find the same quantity. So this was the supply curve, Q equals 4P. Okay. So Q equals, slowly catching up here. Okay, so the supply curve, I found Q is 12. Now I'm going to do it for the demand curve as well, just to make sure that I also find that Q is 12. So 18 minus 2P. So Q equals 18 minus 2P. Substituting in P is 3 still, so Q is 18 minus 2 times 3. Q is 18 minus 6, so Q is 12. That's a good sign. That is great. So, what I want you to do, just to kind of finish this question off, is let's just plot it in Desmos just to make sure that we found the right values. It feels like we did. It works for both the supply and the demand curve, right? So, but remember, we're just solving a system of equations and we're finding the point of intersection, and we've got a quantity and a price instead of X and Y. But they are the same. So I'm gonna, the only thing when I'm plotting this in Desmos, I'm gonna need to use X for Q and Y for P. So I'm gonna grab these because I'm sick of scrolling around here. Copy. So we can check our work in Desmos. By replacing Q, office hours, by replacing Q with X and P with Y, right? And then I'll just paste this in here. So your supply curve, in Desmos, you only have X's and Y's, so that's why we have to make these substitutions. But what you're going to draw is X equals 4Y, and then that's your supply curve. And then for your demand curve, you're going to draw X equals 18 minus 2Y. So here we go. X equals 4y. That's one line. And I could have gotten you to draw these supply and demand curves. We're not doing that this term. The second line is X equals 18 minus, I want to say 2y. Is it 2y? Let me just check. Yeah. So it looks like my point of intersection is over here. And when I click it, whoa, I get X is 12, that's my quantity, and my Y is 3, that's my price. Looks like things check out. Okay. Good. So instead of starting a fresh section, how about we end it there and just work through some of those problems, and I'll give you some on your next assignment that I'll post today to work through as well. Okay. The assignment that I'll post will probably include some stuff for from next day, so it's not going to be due for another week, so don't worry. If there's something that you come across that we haven't covered yet, don't worry about it quite yet, but I'll post it just so you have it. All right. Any questions? Kind of a mixed bag today, but hopefully it's all good. And I'll see you on Thursday.